Well, I guess I'll go ahead and get started. All right, everybody, welcome to OpenPOWER porting platform for free and open source software using OpenStack at the OSU Open Source Lab. Here's kind of a summary of what I'll be talking about today, how we created it, kind of what we looked into with what the projects need for porting, and also talk about the continuous integration platform that we created. A little bit about who I am. I'm the director of the lab. I started the Open Source Lab back in 2007 as a sysadmin. Was promoted in 2011 to director, and I manage about 7 to 10 undergraduate students. I've been active in the open source community for many years, originally with Gentoo, then with a project called Genneti, and more recently I've been involved with Chef and OpenStack Chef quite a bit. So first things first, what is the Open Source Lab? And what services we provide. So first thing I'd like to mention is we're basically an infrastructure hosting provider. You can kind of think of it as a co-location hosting provider for large or medium open source projects. But that really means a wide gamut of things. That could just mean server co-location, it could mean private cloud hosting, it could mean our popular Mirror, which is really popular, or we also can manage the hosting of a project that doesn't really have much sysadmin experience and they just want to have their site and all their applications they need working and so forth. The other half of it is that we're an experiential learning environment for undergraduate students. So we hire students and they work for us and we give them hands-on experience doing production stuff that we have. They work really close with the open source projects. We treat them as our customers and they set up and they manage the services, they communicate with them. We try to teach them new and current DevOps practices, technologies, the best that we can as long as we can keep up. And many of our alumni have gone and done amazing things in the world. Probably our most impactful is Alex Polvey and Brandon Phillips, who both co-founded CoreOS, which is now was acquired by Red Hat and IBM after that. but yeah, we have lots of people out there. Currently, I'm the one full-timer, and I have 8 undergraduate students. That changes throughout the year. So what do we provide specifically to OpenPOWER? We provide that neutral hosting provider for projects that have access to that platform. What we strive to do is create a stable and flexible development environment for projects to be able to port their software to OpenPOWER. We work with IBM to architect and maintain the physical infrastructure, and work with IBM as we run into issue, and we also enable the access to power and GPU resources to all these projects. We also work on computing resources to test large-scale testing and porting. We also have lots of continuous integration backends for OpenPOWER, and we also provide software build computing resources for downstream users. We've had quite a history with Power and porting. I think it started back in 2005, actually before I started at the lab, with a single Power5 server with shell access. And we only had a few projects using it. We really didn't have a lot of collaboration with IBM at the time. They just said, here's a machine, go do stuff with it. And by the late 2000s, we started hosting a lot more systems. So at first we had 6 Power7 servers. We would do all the grunge work with getting the LPAR set up and giving access to the projects and deal with all the hardware headaches. And that was great. It moved forward. We also hosted some dedicated hardware for the GCC Compile Farm project and a few other projects as well. Then in 2011, we really bumped up a lot of what we were doing with Power. We started working on the next generation with Power8 and figuring out how to do what we did on the Power7 servers, but do a better job of it and make it more flexible. And that was utilizing OpenStack, which was really big at the time, getting up and up and up. So we actually started out with pre-development Power7 Plus machines that had Opal firmware that made it think it was Power8, which was fun and buggy. But it got us started. This is before Power8 system even got in. I think we actually got one of the first Power8 machines at the time. But it got us to the point where we can develop and get the stuff going and figuring out what we needed to do. Once we got that up and going, we quickly replaced those Power7 Plus machines with Power8 and then eventually Power9. And we currently host about 100 projects on 9 different kind of machines that we have right now. So when we talk about porting, what do we really need? What do FOSS projects really need? And the thing about our experience at the Open Source Lab is we have a really great relationship with the projects. We know what their needs are. We know each project has a different need and what they may or may not want. So one thing we want to make sure we do is provide easy access to the computing resources they need. Whether that means development or architectures troubleshooting. We also provide the continuous integration testing, and also if they want to integrate that actually in their own CI build system they have. And also part of that also is putting in their binary builds into their pipeline as well. The other thing is that we want to support as many operating systems and platforms and versions that we can. So we do that within the best reason we can, and just basically giving them enough raw resources to do what they need to do. So giving them enough disk space and performance for doing testing and building, providing enough RAM to being able to do the types of builds and testing that they need. And the last part, depending on the project, having an API to be able to drive spinning up and spinning down instances for automated testing can be really important. Not every project needs that, but it can be really useful for doing multi-node testing, for example, and if you wanted to test between two different nodes doing stuff. So we knew that going in. So what we provide is the OpenStack Power Cluster. We provide compute, networking, block storage, and orchestration. We have pre-built images that we provide. We currently have Ubuntu, CentOS, Fedora, Debian, and OpenSUSE. For access, we provide API access and deploy, or we can deploy the VMs for them if they don't want to deal with the API access. And that also means giving them the web GUI interface. So if they want to get on the console and troubleshoot things, maybe do some kernel development, they could potentially do that. We do have some larger projects that have dedicated bare metal access to their own systems that are outside of this cluster. So that includes the GCC Compile Farm project. Debian, Alpine, and FreeBSD has their own systems as well right now. And that kind of comes with the collaboration we have with IBM and allocating those systems. We basically try to make it as flexible as possible for these projects. On the flip side of it, we deal with all the hardware support so that all they worry about is being able to SSH into an instance and being able to do what they need to do. For those projects that have the dedicated bare metal access, we make sure that the machine has all the firmware updated, everything's configured properly. We know how to configure the RAID on it, which can be a little weird for some of these projects coming from an x86 world. We just have all that experience over the years of knowing how we can give advice to these projects. And then when we get into a bind, we always can reach out to IBM engineering support to kind of figure out why are we running into this issue. I remember early on, we actually found an Opal firmware bug that they hadn't seen out in the wild yet, and we got them to fix that. That was kind of fun. So here's a quick synopsis of the kinds of projects that are using this platform right now. Docker's using it right now to build all of their PowerPC Little Indian Docker images are built on this platform. Travis CI is doing some beta testing. I've been working with Garrett quite a bit on that. Some of the jobs that go through Travis CI now go through our system. And then a whole bunch of other projects that we provide resources for, whether it's just part of their CI, development, testing, you name it, it's in there. So it's quite a bit of projects that we encompass, and it grows and grows and grows. And what I wanted to show was I was looking through the number of tickets that we've gotten over the year, starting in about 2015 when I could go back that far in our ticketing system to kind of see what was going on. You can see the growth that happened between 2015 and 2017. I'm not really worried about keeping that going up and up and up every year, but you can kind of see where we had this peak, and now we're just kind of maintaining, and it can go up and down based off of, word of mouth, people knowing about it, and knowing that this access is here. So as of 2019, we have, I think, about 25 projects that we've brought on. And all of our students actually do the work of getting projects access. So we have a process where they fill out this form, and then we spin up the VM, or we give them the access, and we go through that. And so our students do all of that. Now, the part that I really enjoy doing is the technical side, and that's actually how did we create this platform in the first place? So I'm going to talk about our architecture and design, the challenges we made, scalability challenges, and kind of some upcoming changes we're going to be dealing with. So currently we're running the Queen's release. We're 2 major releases behind right now. I did a lot of upgrading of our OpenStack in the past year to get it up to where we need to be. We have the following services enabled, which is what most projects need. We may add to that as we see fit. At the lab, we standardize on CentOS. And so we're currently using CentOS 7 as our host operating system on the hypervisors. And we use Chef as our configuration management tool. And so that's how we manage all of these. Not to give you too much chef jargon, but we have a wrapper cookbook that's publicly visible on GitHub that shows, oh, it's still working, okay. That shows kind of how we have these things configured. And that actually pulls in upstream cookbooks that the OpenStack community, and I'm a part of, maintain, and how we can configure all of that. Another change that we made was we're actually running a mainline LTS kernel on all the hypervisor nodes. That's just to ensure that we get the latest and greatest boost and things that we need out of the kernel to run on these systems. We were starting to run into some issues where the kernel was coming from CentOS was having a few issues, and we wanted to make sure we got ahead of that. So, of course, running our own mainline has its own set of issues sometimes that we've run into, but it also helps us kind of make sure that, you know, if we catch anything, we can kind of get it fixed more upstream more quickly. Another thing that we wanted to do is we can't build this cluster to be for testing performance. We've had several projects come and like, hey, we want to be able to see how fast this runs compared on x86. And we're like, well, you could do it, but you can't. You're on a shared resource, and depending on what you're doing, whether it's I/O bound or whatnot, you're going to be contending against a bunch of other projects. So we can't guarantee what it is that's going on. My counterpart Chris, he does all that kind of stuff where he can test it and actually see what's going on. I'm not wanting to do that. I just want to make sure that the system works the best that we can at the best effort, but I can't guarantee it's going to be great for testing performance. So that's kind of another part of our design. Currently, our hardware, we have 6 POWER8 machines and 4 POWER9 nodes. They all have 512 gigs of RAM. That was something initially we only have 256 gigs. That wasn't enough because projects really liked having RAM on their VMs. And thanks to a donation from Mellanox, we had a 40 gigabit switch that we interconnect all of those nodes with. More recently, we got 5 storage nodes that are POWER8 based to act as a Ceph storage cluster. We're currently running the Mimic release, and it has almost 300 terabytes of raw disk storage. And we're currently only using about 20% capacity of that cluster. So we're doing pretty good on the capacity side. And then we just have one controller node that manages all of the various API services between all those nodes. So the backend storage was something that one of the challenges we ran into early on. When we first started doing it, we just put it in local storage. We had the system set up with a RAID 5 with spinning disk SAS disks using LVM and iSCSI as a way of connecting. But the problem we ran into is if we needed to do any maintenance on the hypervisors, rebooting the node would cause many issues. So depending on, I couldn't do live migrations, and if I rebooted a node that had the storage was there visible, but then it went to another machine, everything would just not work. And then we also ran into a lot of I/O contention and capacity issues. We couldn't scale the storage up that we wanted to be able to do because it was based on those nodes. So in 2017, I really pushed IBM to get us some, to push so we can start using Ceph, which is a first-class storage citizen now in OpenStack. And so luckily they were able to donate those storage machines, and I was able to get that deployed early on and migrated everybody over from the local storage over to the Ceph storage in April of 2019. After we did that, we saw a huge performance boost. And the other benefit was we were able to do live migrations of the VMs. And especially since we're doing it on the 40 gigabit network, it's really fast. So that way we could deal with upgrades we could take a system completely down, but before we do that, we can migrate all the instances off of that onto the remaining nodes we have, reboot the node, do whatever we need to do with it, and bring it back up. That made it a lot better. And then also it made scaling our storage a lot easier. So now if we ever, for whatever reason, run out of storage, we can buy another server or buy bigger disks and just put it in there. And with the way Ceph works, it's really easy to do. I can reboot those nodes as long as they do it correctly, and the storage doesn't go down. So that was really our biggest change we've done in the past year, was getting Ceph working and tuning it, fine-tuning it. So here's some hypervisor usage that we have. So we've been using POWER8 for quite a while, so there's quite a bit more POWER8 VMs now than there are POWER9. So on average, I'd say we got about 45 virtual machines running per hypervisor node. And this is showing since about February, since I started tracking all of this information. So this is showing the POWER9, this is the POWER8, and this is the total between both of them, what's going on. So since we moved over to Ceph, the POWER9 nodes are actually just 1U-based nodes. They don't have a lot of storage. They don't need it, and it makes it a lot easier. We could pack a lot more POWER9 nodes as we need to. So we only have about 10 VMs per node running on that, but that's hopefully going to be changing. More and more people are going to want to do things on POWER9. Here's some snapshots from our dashboard. So this shows over the last 7 days, the cluster load. So this is showing actual CPU usage across all the hypervisors, the actual load on the machine, disk capacity, the cluster memory usage. So you can kind of see our limiting factor right now is mostly in the RAM, so we kind of have to keep ahead of that. We have 265 VMs. You can see POWER9, POWER8 VMs. We have 107 projects right now registered that are using this. And yeah, it's going really well. Here's another set of graphs that I have. That's the same one I showed before, but this is showing all of the VMs. Let's see here, trying to think of some other interesting things here. You can see the disk throughput on the Ceph cluster. There's lots of writes going on. I don't know if you can see it from here, but it's doing about 100 megabytes per second on a lot of the writes. And then this kind of shows you the overview of all of the hypervisor nodes. The naming scheme doesn't quite make sense because we renamed some things at some point, but this is a POWER8, 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 POWER9, POWER8, POWER8, 9. This is a development machine I use, and I sometimes pull it in, but that's POWER8, and that's 9 and 9. So this is showing CPU utilization. So you can see my POWER8 systems are getting pretty hammered pretty well, and I'm trying to get more people to use the POWER9 systems because they're faster and they have more capacity right now. And you can see our memory usage on the systems, and then you can see a little bit of the network usage that's happening down there. A lot of that network usage is just coming from Ceph itself. If I dove down in there, you could actually see how much actual public internet traffic that's coming off of it. So the systems are being used quite a lot. This is a dashboard we use on Ceph to kind of see what's going on. So we can see how much cluster I/O is happening. We can see the latencies of the various hard drives, and we can also see the capacity and how everything is going. So it's really helpful for diagnosing issues. There's a lot more graphs that we have in there that I can't show you, but there's quite a bit of stuff. So some of the initial challenges that we ran into, since we started so early on with POWER8, there was very limited support for us to start out with. So initially, CentOS didn't have any PowerPC Little Endian support at all. So we actually started out with Fedora back in the day, and then we switched to CentOS. Back then, Chef didn't actually have a build for Power quite yet, so we had to build our own. They now have that. And then a lot of the binaries that we use, especially from the OpenStack binaries from CentOS called RDO, didn't have PowerPC Little Endian. They still don't. The good news is most of them are just Python packages, so it doesn't matter. But there's a few that are, dependent, that are actually binary. And all we do is we just pull the source RPM from their repository. We build it on PowerPC, and then we put it in our own repository and just configure the node to use that. When we moved to Ceph, CentOS and Apple and all that actually has a build for it, but we wanted to track upstream. And upstream Ceph didn't actually have PowerPC Little Endian images. I reached out to them, but they weren't that interested in doing that. Although since they're a Red Hat company, maybe that'll change. So I actually built those ourselves as well. using the source RPM with a few minor modifications to get that going. We also had some initial hypervisor problems. There was bugs in QEMU and libvirt that we had early on, but we don't have anymore. And then we also had some issues on POWER8 only with a contiguous memory allocation, where the way POWER8 works with KVM, it allocates contiguously the amount of memory you want to have for doing live migrations. And we got to a point where we had enough physical memory on the system, but we didn't have enough contiguous memory to add another VM, and so it would stop adding VMs. So we had to make a kernel adjustment to kind of do that. And we still hit that from now and again, but it hasn't been that big of a deal. And then in all of this, we had to learn OpenStack and then Ceph, which was a lot of work and a lot of uptaking, but our students really have a lot of fun learning about how all this stuff works in the back end and how it all kind of fits together. Some other things, when we wanted to build guest images, we used a tool called Packer, and at the time, Golang hadn't been built on PowerPC. And Packer is built with Go. And so we had to build our images manually. And then finally, actually, once we got Golang on our cluster and they started building it, we could actually finally build Packer. And now I think Packer actually has its own build of PowerPC, so that's been great. All of our templates on how we create our images are in that GitHub repository. It also includes our x86 stuff as well, but it's at least a good starting place for you. And the other challenge we have is just doing upgrades of the software. So OpenStack has a 6-month release cycle cadence, and they add a lot of features and adds a lot of bug fixes as well. And early on, OpenStack was not really good at doing in-place upgrades. We actually, through the process, we used Nova networking, which got deprecated into with Neutron networking. And there really was no way to migrate that in place. And so we actually had to create 2 separate clusters at the same time and migrate people over when we did that. Thankfully, we never had to do that again. But we had to come up with a way of doing in-place upgrades without impacting the customers. And so we've been able to do in-place upgrades fairly well since, I think, Mitaka. So everything is alphabetical order, so we went from M to Q. And that's been a big headache. When we got to Ceph, we had that as well. We've done our one-time migration from, there we go, or one-time migration from, let's see, Luminos to Mimic. And that was pretty easy. That was a lot easier than OpenStack was. But we just had to do a rolling upgrade on all the various things, and everything in the back end worked. So we wanted to make sure that our users had the ability of not knowing an upgrade was happening and that their VMs were still running. The only thing that got impacted during the upgrade window is they couldn't create new VMs because that black plane was down while we were doing that upgrade. So that was a challenge. And it still is a challenge, but it's getting better each time we upgrade. So another thing that we did over the past few years is built in some continuous integration. This is basically a Jenkins instance that we manage that ties into OpenPOWER. This is really intended for projects that don't already have CI and they just need to run some simple tests or doing some simple builds. A lot of these are actually internal IBM projects to work on it, but it works really well. So what we've done is we've integrated Jenkins with GitHub with OAuth access, so you just give us your GitHub username and then we add you to the authentication and you can do what you need to do. We have 4 VMs that are actually running on this OpenStack cluster. 2 are POWER8, 2 are POWER9. We have Docker set up on it, and how Jenkins is set up is that you create a job and the job runs inside of a Docker container on those nodes, and then it stops and it goes on from there. And so some of the projects that are using it currently are TensorFlow, PyTorch, Envoy, and Onyx. So yeah, we've gone through a couple of iterations on how we have this deployed. There were some Jenkins plugins that we used initially that didn't quite work, and we redesigned that a little bit. Here's a snapshot of the usage of some of of these 4 VMs. So Docker 1 and Docker 2, this column is the POWER8 and this is the POWER9. The original way we had this set up, it didn't really balance the load very well, and the change we made more recently seems to do that. However, I don't know why Docker 3 hasn't gotten many jobs in the last 24 hours, but it's not that bad. So this shows what's kind of going on. We've had issues with disk capacity. We had one, I think it was PyTorch, or I can't remember who. All of a sudden, these nodes, I think, have 200 gig of disk capacity now. I started with 100, and we had one job completely fill that up, and I just emailed them and be like, hey, something's not right. We didn't have this problem before. And they're like, oh, shoot, yeah, something's not right. We got to fix that job. So something else that we did is we worked with the CGRB to get access to one of their systems so we could actually integrate with so that we could do CI on GPUs. So this is just doing development or CI usage, not performance per se. So the hardware stack is we have a loaned Minsky from the CGRB that has 2 P100 cards in it. We don't need the latest and greatest, we just need something that has the GPU so they can do tests with it. These systems have an NVMe on it, so we have Docker connected, mounted onto that, so we get really good I/O. And we're using Nvidia Docker so that we can do several different types of platforms on there as you need, all on that same GPU system. So we've integrated it into the PowerCI Jenkins instance. It's working really well. We initially did this through the CGRB's queuing system, through their SGE Son of Grid engine system, and it kind of worked, but it was really finicky, and it really didn't work the integration on the user experience did not work really well. So I worked with them as like, can we just have root access on this machine and just manage it like we normally would? And thankfully they were able to do that, and that's just what we ended up doing. This is the specific plugin that we use for projects to be able to use. So basically this node is a Jenkins slave, and then when you go through the Jenkins, you can say build this as a Docker image, and then we have a label set which goes to this node and then it runs. Here's a graph that we have for showing the GPU usage on this machine. So this is the power usage of the GPUs that are running, how the temperature of the GPUs, and then this is actually showing the usage of it. So you can see when each job runs, I think there's only a couple jobs that are running on it currently, but you can see that it's running and how much memory it's using. It's not using a lot, but it's really, really good. So some upcoming changes that we're looking into. One big project that I'm working towards is getting GPU integrated more into OpenStack. So my goal there is to be able to give projects access to have a more interactive access to GPUs instead of just through CI. And I discovered, I think actually at the last OpenPOWER Summit, a group of people from the OpenStack Zoom project was here talking about it. But there's a project called OpenStack Zoom which enables, it treats containers more like VMs. Instead of dealing with orchestration, which is a completely separate project in OpenStack, it's great for having like setting up a container to do a specific thing. And since we can use Nvidia Docker to interface with the GPUs, in theory we should be able to create a Docker image that has SSH on it that you can just SSH to it and you have access to the GPU to do the testing and things that you need to do. So we're not quite there yet. We need to get to a newer version of OpenStack, which includes the support we need on the networking stack to do that properly. But I did do an initial test on the current version we have. We need to get to Stein before we can really get to using this, unfortunately. So we're 2 releases behind to get to there. So I'm going to be really excited about that once I get that going. Also, just continuing to upgrade to the latest software releases. So actually the Chef OpenStack, or the OpenStack Chef community is a little behind on getting their cookbooks ready for Rocky. And I've been working with some of the upstream guys on getting that ready, and that should be going soon. And then shortly after that, we'll work on getting Stein going. And then we'll get over, I can't remember what the T release is called, but we'll probably get to that at some point. But I'm hoping to at least be no more than 1 release behind to kind of keep things going. The Nautilus release came out in April, and so we're going to try and upgrade to Nautilus soon. It should be a fairly minimal upgrade, but that gives us a little bit more capability of doing things. And then whenever CentOS 8 gets released, which I'm closely watching, I think they're really close to releasing, we'll probably start testing that and preparing our underlying infrastructure to use CentOS 8 so that we can get on the latest and greatest. That'll probably be a fun project to get going, because there's probably going to be some weird issues going on with that. So with that, do you have any questions? And if you want, here are the URLs to get access to the OpenStack environment and then the PowerCI environment.
You talked about your chef recipes.
Uh-huh.
Do you have anything that directly talks to like the OpenVMC part of the system? Or?
No.
It's all OpenStack.
Yeah, we had been looking at, there's a project called Ironic that OpenStack has that allows you to do that. At the scale we're at, we're not spinning up machines that often, so we're not needing that. But I have been interested in using Ironic as a way to provide more bare metal access to systems. So if projects want to be able to get access to a system, Ironic will talk to the BMC to get it set up, and they can do that, and then we can repurpose that machine. But we do all the BMC stuff manually out of band as we want to do it. We connect to the serial over LAN, and we run all those commands. We do all that remotely so that we can run that and manage those systems.
Do you save your logs and you do any post-analysis of your infrastructure in general?
We do, to a certain point. That's something I'm continuing to work on. There's actually, OpenStack has its own logging mechanism that I've been trying to get going, and it's not currently working right now, which is frustrating me. But like raw logs, we do keep those for quite a while, but like those graphs you see, we're keeping those. We deployed Prometheus and Grafana in the past year to kind of get a better visibility of what's going on in there. And so that enabled us to kind of see what's going on. So OpenStack has some of that features as well. Yeah, we're trying to do a better job of tracking that. Is there specific metrics that you're interested in?
No, I'm asking because we have clients that want to use AI on their logs, and so we're also looking for data. And guinea pigs.
Yeah, one big project I've been wanting to do with our infrastructure is getting a centralized like elk stack kind of set up in our environment, but we've never really got around to that. We just have a standard centralized log server for all of our stuff, which is at least good for archiving, but not really good for searching per se. So. Any other questions?
You don't have interactive access to the GPU nodes at this point, right?
Correct.
You're using a Docker container, which is controlled by Jenkins, that's in your possession, your control, to kick off your jobs on that particular node, right?
That's correct.
Okay. Can you extend a little more? You mentioned that OpenStack project for providing interactive access to Docker nodes, right?
Mm-hmm. Yeah. So it's called Zune, and it basically interacts with Docker, and it uses same set of technology that Nova uses for connecting to the console and so forth, but they're doing it to the Docker console to get access to that. There's a networking layer that they're still working on, which is why I need to wait to get to the later release, because they've worked out a lot of it. Most of the upstream contributors are in Japan, and I think they work at a bank or something. They're doing a lot of GPU development stuff, and that's why they're interested in doing this. But instead of like setting up a Kubernetes cluster, it'll set up individual Docker containers. It'll manage all of that. It'll treat it like an OpenStack object inside of OpenStack, which has all of its benefits. It has a Horizon GUI interface as well. They do have a console part, like I mentioned, that I haven't quite got to work, but I think it's because I'm using an older version of it. I think it was initially released in, not Rocky, but Pike was the first release it came out with. So it's still a pretty early project.
Do you think it would be a completely different usage model from using Ironic to provision the bare metal systems and giving interactive access to
I wouldn't be able to, I only have a limited number of GPU nodes, so if I do that, then I have one user that has access to one whole machine, and I wanted to oversubscribe that machine. And so I could do that with something like this, where I wanted to have access where multiple Docker images could be running, multiple at the same time. They could also access the GPUs at the same time. And I wanted to oversubscribe, kind of like what I've been doing with VMs as well.
I think Nvidia Docker only allows you to partition the GPUs, right? They don't oversubscribe them, right? Or them.
I think you can. That's something else I've been trying to find testing to see if I could do that, but it seems like you can, because we've had multiple jobs running on the GPU system sometimes, and that's been working. Because I think they have some Larry shim that works with that, since it's basically containers on the bare metal machines. It's just set up differently. Let's see. I've got a little bit more time if there's any other questions. All right. Well, with that, thank you for coming out and enjoy the rest of your week.